Welcome to this video on the student t-distribution and t of alpha over 2. Let's begin. After watching this video, you should be able to find alpha given the confidence level of a confidence interval, and find alpha over 2 given the confidence level of a confidence interval. You should also be able to define t of alpha over 2 and explain how it relates to the confidence level of a confidence interval. Here's a summary of the t-distribution. Recall that the shape of the t-distribution changes depending on the sample size. T-distributions with sample sizes smaller than 30 have much fatter tails, while t-distributions with n close to 30 begin to resemble the normal curve. What is alpha? Alpha is the area to the left and right of the middle portion of a confidence interval. Below, a 90% confidence level is illustrated on the t-distribution. The combined area in the two unshaded regions to the left and the right of the shaded region is 10%, or 0.10. This is alpha. We can use the following equation to find alpha. Alpha is equal to 1 minus the confidence level. This is a pretty important equation. It will not be supplied to you, so you might want to write it down. So in this case, alpha is 1 minus 0.90, which is 0.10. You could also think of it as 100% minus 90% equals 10%. Historically, t-tables have been used to find the area under the curve. Notice that the header row lists common values of alpha. The left column lists something titled df. df stands for degrees of freedom, and it can be calculated using the following equation. The degrees of freedom, or df, is equal to n minus 1, where n is the sample size. What is t of alpha over 2? Here's an example of a t-distribution. In this course, the notation t of alpha over 2 will be used in confidence intervals and in hypothesis testing. In confidence intervals, the shaded region is the confidence level, which is also the same as 1 minus alpha. Some common confidence levels that we have seen, or that we will see, are 90%, 95%, etc. The unshaded region collectively is referred to as alpha. So the area in the left unshaded region is half of alpha, or alpha over 2. Likewise, the area in the right unshaded region is also half of alpha, or alpha over 2. T of alpha over 2 is the value of t that separates the middle 1 minus alpha portion of the graph from the rest. As you can see from the graph, there are actually two values of t that do this. They have the same absolute value, but they have opposite signs. When working with confidence intervals, we will always use the positive t value in our calculations, since we want our margin of error to be positive. Here's an example of a t-distribution with n equals 12. Suppose we were asked to find t of alpha over 2 in order to construct a 90% confidence interval when the sample size n is 12. So again, the confidence level is 90%. Recall that alpha is split evenly between the two unshaded tails. First, let's find alpha. Remember, alpha is 1 minus the confidence level. In this case, that's 1 minus 0.90, or 0.10. So if we know that alpha is 0.10, how do we find the area in each tail? We simply divide by 2. So alpha over 2 is 0.10 divided by 2, or 0.05. So the area in each of these two tails is 0.05. At this point, we're going to have to use technology to find the t-values that separate the middle 90% of the data from the rest. We can use t-tables or software. If you think about it, t-tables are really the technology of the past. In the past, before computers and modern technology, people would sit down and tediously compute the t-values for different degrees of freedom, or different sample sizes, and different confidence levels, and then they would fill out that table. So using software really isn't any different from using a t-table. It's just the technology of the past instead of the technology of the present. At this point, I'm going to end this video because, again, how you proceed depends on the technology you want to use. So you're going to have to use a different video to actually practice finding these t-values. So now that you've watched this video, you should be able to find alpha given the confidence level of a confidence interval. You should be able to find alpha over 2 given the confidence level of a confidence interval. And lastly, you should be able to define t of alpha over 2 and explain how it relates to the confidence level of a confidence interval.